Alright, so in the last video I showed you shit like this, and I typed it wrong. Wow, I'm not good at typing. That's just kind of a chronic problem here. So I used this example, and I typed it wrong, and in the, whatever. So this one, technically it's +1, -1, and I'm saying it aloud so that I, hopefully, even if I type it wrong, +I, you can still see what I'm doing. I and 1 look a little bit too similar, so if I type it wrong and I'm talking about other shit, it's not going to stand out to me. So, yes. That's the wrong... That's a 4. If it were a 2, then it would just be these guys, right? If it's this, it's those. If it's this, it's... Woo! What the hell? That. There we go. I knew there was a keyboard shortcut that got me back to that. Yeah, there you go. Okay. There is something... I have a really bad habit of doing that. There is something even more amazing about this. Okay. So pretty much what happens is whatever the number down here is, it sort of tells you how many parts there are. Depending on the coprimality of the numerator and denominator, that can of course fluctuate, right? But, you know, so like 3 on 12, you're not going to get 12 roots, or, you know, you're not going to get 12 solutions. You're still only going to get 4 because that's 1/4, right? But this one is beautiful. What if we have this to, let's just say this, where k is irrational. What the hell happens now? Oh my god. Well, guess what? If you were to try to write k as a fraction, how big would your denominator have to be? That's how many solutions you get. Yeah, so +1 to the k, where k is irrational, yields an infinite number of solutions. Now, I'm not remotely sure about the density of this, but it... something like... Wow, okay. Things like... Social media has taught me to hold shift while hitting enter so that I can actually put paragraphs in. So it just ends up being a bad habit. And here, shift enter, whatever. It tells it to copy the list. And it thinks that thing is a list. Anyway, so something like this guy. I do want one of those, just not like 10 of them. So something like this. Oh my god. It gives you the whole, I think, maybe? The whole complex unit circle? Maybe? There might be holes in it. I don't know. I don't know how you would ever determine that. Certainly, it gives you at least all of the... integer divisions of it, right? So like, you know, you take the orbit around the unit circle, it gives you 1 for sure, +1, and then you can cut it in half and get -1, and then you can cut it into fourths and get I and -I. You can cut it into thirds and get those in the sixth and the ninth and whatever, right? So like all of those for sure. But you could also have like irrational multiples of pi in there. So I don't know. I think it's probably just all of it. But it gets past what I can understand at the moment. So there might be gaps. And I'm not expecting that there's gaps. But I do sort of expect that for some irrationals there would be. Maybe. So that's an interesting question. It's definitely going to give you an infinite number of solutions, but does it give you the entire unit circle, or are there gaps? Is it somewhat sparse, or is it fully? I don't know. I don't know. But that one's crazy. So it goes immediately from, say, like, wow, see? I never learn. We go immediately from, say, like this, I'm going to say, sure, 6, which is just this, to, haha, I do learn, to, okay, nope. 6 plus, remember this guy. This just gives the entire unit circle. All right, recalling that this one, it is the immediate neighbor to the left of 0. Right, so the smallest possible value, which obviously you can't measure that. You can't measure it in a number system. It's irrational. It's ridiculously small. It's unachievably small. But it definitely exists, because when we take limits, that's the interval away from the value that we want to evaluate that we are actually evaluating at. So it's absolutely a real thing, and we use it. But that's what that is. So as soon as you just pull away from one, just the tiniest bit, you go from having one solution to having the entire complex unit circle as your solutions to this power. That's insane. That's insane. And then probably even the one next to it still. And then the one next to that. And you have to go an infinite number of these infinitesimal steps before you get to a rational value. And even at that point, you're going to have a stupid number of them. It's going to be ridiculous. It's going to be unmeasurably dense. Even then, even though it's now pretty much, compared to what it just was, there's really almost no solutions. It's almost all empty space at that point. Yeah, there's really amazing things are happening here. And somehow this is fundamental to how exponents work. I've never seen any of this discussed. I'm pretty sure almost nobody, if perhaps nobody, is even aware of this. But it's just right here. It's not hard to see it. Kinda crazy.